So the video that I did this morning was to add a spur to a ring final circuit. I've actually put off doing this particular job or this video for a while now because I know that I'm going to get a barrage of criticism for some of the things that I have done. Namely, a couple of the things being having the children in the video and also with the dog making an appearance, and I think a couple of times the customer actually came in and asked me the odd question. However, this is a real life situation. This is a job that had to be done slightly different to a classroom where it's a nice controlled environment. But I've done the video to promote discussions, how things should be done, how things shouldn't be done, etc. Hopefully you'll think I've done a good job, especially my adult domestic installer learners, so they can see of some of the problems that we can be faced with in the working environment. But yeah, so hopefully you'll enjoy watching the video and we'll see what happens. Thank you. So this morning I'm at a customer's house. I've come to install a 13 amp double socket. It's a click mode double socket, and I'm going to be installing it up here for the TV that's been installed on the wall above. At present, they've got the 13 amp double socket down below on the floor, and they just run the lead for the TV down. It just looks a bit of a mess. They want it installing up there out the way nice and properly. The TV aerial has already been installed, so the TV is actually working. They just want the power. As you can see, I've got children in the house today with me. Your little sister. And so it's really important for me to be carrying out safe isolation, so the circuit is completely safe. But obviously this is some of the problems that we might encounter. That's why carrying out safe isolation, having the appropriate signs, the appropriate lock-off kit, etc. So the circuit is completely safe, and that's what we will be doing. I'm going to be taking a spur off this socket here, this 13 amp double socket. It's part of the upstairs ring final circuit. Before I just add a spur to this socket up there, I need to determine a few things. When I came over to look at the job, I did a few checks, some visual, some with my test instrument. Initially I checked that it had a 32 amp circuit breaker controlling the circuit. That tells me that it could be an A1 ring final circuit. I then carried out a end-to-end test on the line, neutral and the CPC. Again, that gave me a very satisfactory reading, so I was perfectly happy with that. And then I checked to make sure the ZS, I carried out a live test, I carried out my ZS test, and that was just carried out on this socket. Reading needs to be below 1.1 ohms, and that would tell me that it's a healthy circuit. If, for example, the circuit was, the reading was above 1.1 ohms, I wouldn't necessarily be able just to add a spur to this, because the circuit breaker, in case of a fault, might not disconnect in the correct time. So there's a few things that you have to be checking before you just go along and add a simple spur to a circuit. Just to show you what we did, I've got my MFT here, so I plug it in. It's already, I'll set it to to check the earth fault loop impedance. My ZS test. Turn the socket on. It's going through the process. It's a 3-line test I'm carrying out. It takes a few seconds. And that has given me a reading, don't know if you can see that, of 0.65 ohms. 0.65 ohms. That is way below the 1.1 ohms. So hopefully by the time that I've installed the circuit, the spur socket above, that will still be way below 1.1 ohm, because it won't be adding that much resistance onto the circuit. So I've now carried out the safe isolation procedure on the upstairs ring final circuit. It's locked off downstairs. I know I've determined that this socket that I'm going to be working on and the circuit that I'm going to be working on is no longer live, so there's no risk of electric shock or anything like that. What I'm going to be doing is I'll take the front of the socket off. I'm then going to be drilling a hole at an angle through here into the back of this spool here. Along up here is a void underneath, behind here there's a cupboard space, and so I'll run a piece of mini trunking up there, and that way it will save having to chop out all the wall and the plasterboard, and it'll be nice and safe, Howard, and nice and neat.
Matthew reproved safe isolation.
So I'm inside the cupboard now, and we can see the hole has come through. Can you see that there? Hole's come through there, almost in the corner. And then we're just going to run the cable up all the way through in a piece of trunking. It'll go all the way to the top, through the loft space, and then back down to the socket. So hopefully that should all be okay. What I mustn't forget to do is to put a 20mm grommet in the knockout, in the 20mm knockout that I've done, because it's very easy just to draw the hole, chuck the cable or poke the cable through and be done with it. So we obviously have to make sure that there's no sharp edges or anything like that. Let's try that now. And it's really quite awkward to do because it's obviously full of cement, so I'm just having to chop out so I can get the actual grommet in. Right, so we can now see that the grommet is nicely in position, if you can see that well, but it's in position, there's no sharp edges, and it should be okay. So I'm going to mount my double socket up here. It's just going to be a surface mounted. It'll be mounted up here, completely out the way. Okay, bit of a struggle, but I've now cut the piece of plastic trunking in the piece of plastic mini trunking. It's all cut to the right size for me to install now. I'm just going to drill a few holes through, a couple of holes in, and get it secured nicely to the wall. Right, so I've got the cable and I've got the mini trunking and the cable completely installed now. It's obviously not, none of the terminations are done just yet, so I'm going to put the front cover of the mini trunking back on just to keep the cable secured in place so it doesn't keep dropping down. The rest of the cable, there's a couple of meters now of spare cable just coiled up in the loft space, and I'll need to bring that back down, but I'll just get the lid of the mini trunking back on first. Right, that's the cable now through. Been up into the loft, got the cable through. So I've just got the cables prepared before I actually put the surface mounted box on, and I've stripped the cables back to the size that they need to be, double the conductors back, etc. And so that's just what it's looking like at the moment. As you can see, I've just used my impactor drill to screw the surface mounted box back onto the wall. Never go fully tight with this, and the reason being is because it's very easy to break the plastic box, so always just go back over with my posi drive just to give it that final tightness. So just to make sure that the box is level, I'm going to use my spirit level just to check. It's not too bad, it's slightly out, so I'm just going to loosen it off. And just to adjust it so it's perfect. So the 13 amp click Skullmore or click mode double socket. So we have the line, the neutral and the earth terminal. Now been wired up properly. I'm then going to fold the wires back round to bend them to push the socket back on. The problem is now when I push them back on, when I push the socket back to the box, the 2.5mm conductors might become slightly loose in the terminals, or they could loosen off in the terminals. So I'm going to push the socket back. I'm then going to pull it back forward, recheck the terminations and then tighten it up. Okay, so the 13 amps double socket has now been fitted up onto the wall above. I now need to connect it back into the original part of the ring final circuit, and we'll do that now. One of the things I noticed when I unscrewed the socket from the wall was there was quite a bit of resistance to try to actually take the screw out. So it probably tells me that either the screw that I took out wasn't in very good condition, or the actual internal thread of the metal box that's in situ. So I've got my 3.5mm rethreading tool, and I'm just going to run it through the thread, and all that does, it just cleans it back up again, and then hopefully when I screw the screws back on, it should be okay. Really useful bit of kit. And now that screws in much easier, with minimal resistance. There you go, yeah. Okay, so that's the socket, the original socket screwed back to the wall. Obviously I'll need to fill out a minor work certificate because this is an addition, so it could be classed as an addition to a existing circuit, but a minor work certificate will be more than adequate for the work that we have done today, I think.
Dead testing has been completed off camera.
So the final part of the testing, the live testing now, is to determine the ZS for the circuit, for all the sockets on this particular ring circuit, and obviously the socket that we've installed. Okay, the circuit is now live. It's carrying out the circuit testing. Usually takes around 8 to 10 seconds to carry out this particular test. That's reading 0.6. Okay, so now I'm going to turn this off and I'm going to plug it in to the tester above. That's reading 0.67 ohms. That's what the circuit was reading before we started. I'll check the other socket to make sure that's okay. So turn it off, unplug it, turn it back on. Again, 0.67 ohms. This is the reading, that is the value, that is the highest value on this ring final circuit. So that is the value that I will be recording on my test sheet. Again, I'm just going to run through very quickly the procedure for checking the RCD. I've already checked the RCD, I know the RCD operates correctly. But again, we're just going to go through the RCD test as well. So we have the RCD side on here, and we also have the RCD test on here. So this one, we're going to be on the 30 milliamp RCD, 0.03 amps. That's the RCD that we're on today. And then we can go through the auto test. I don't particularly like the auto test. I prefer doing each test individually. So we're on the half times test, and it says it's at 0 degrees. That means it's at 0 degrees of the sine wave, and then we'll test it at 180. We hope at this time it won't trip. So just press, and it should not trip. Okay. We're then going to change it from 0 degrees to the 180 degrees. You can see 180 on there, and we're going to press the test again, and it's running through the test and it's not tripping. Now we're going to move it to the 1 times test at 30 milliamps. This should trip in less than 300 milliseconds. As you can see, it's turned back to the 0 degrees, so we'll test it. And it's tripped within 32 milliseconds. I now need to go and turn the RCD back on. So the RCD is back on. I'll change it to the 180 degrees and press the test button. And that is now reading 25.2 milliseconds. Again, I'll record the highest of the 2 readings, which was the first one. And that will be the reading for the 1 times that I put onto my test results. I'm now going to need to go and turn the RCD back on. It is back on. We're now going to turn it on to the 5 times test at 150 milliamps, and this should now trip within 40 milliseconds. Again, it's gone back to the 0 degrees. Press the test button, and it should be tripping less than 40 milliseconds. That's tripping in 17.1. Now I need to go and turn the RCD. So again, the RCD has been turned back on. I'm going to turn it back on to the 180 degrees. Freddie, do you want to do this next bit for me?
I'm going to my grandma.
Just have to press the test button. Come press this button. So this is young Freddie. He's going to turn it on. Just press it.
Pressed it.
He's pressed it. And that has now tripped in 7.2 milliseconds. Okay, do you think that's good, Freddie? Is that a good time, Freddie?
Yeah.
You happy with that?
Yeah.
Okay, so again, I will record the higher of the two results on this one, which was the previous